this next problem, we want to isolate the absolute value by itself, which means we want to add 7 over 6 to each side. We notice on the right that we're going to need a common denominator of 6, so the 1/2 we can rewrite as 3/6. We now are going to have the absolute value of 2 minus 1/3 p equal to 10 over 6, which can be reduced to 5/3, as I will write on the next row. When we have an absolute value equal to a number, that can now be split into two equations. 2 minus 1/3 p is equal to 5/3, or 2 minus 1/3 p is equal to negative 5/3. We're going to want to clear the fractions in each of these equations by multiplying through by 3, which is the least common denominator. Our next line will read 6 minus p equals 5, or 6 minus p equals negative 5. Subtracting 6 on each side of each equation gives us negative p equals negative 1, which means p is equal to 1, or negative p is equal to negative 11, which means that p is equal to 11. And we have a solution set containing the values 1 and 11. In this next problem, we have absolute values on each side of the equation. We're going to take the left side, 2a minus 3, and set it equal to a plus 2, as if there were no absolute values. But we will also take into account the possibility that what is inside each absolute value is opposite inside, meaning 2a minus 3 is the opposite of a plus 2. We'll now solve these two equations. In the first case, we are going to subtract a on each side. This will give us a minus 3 is equal to 2, meaning a is equal to 5. And on the second equation, we'll begin by distributing the negative. We will have 2a minus 3 equals negative a minus 2. We will then add a to each side of the equation, and we will add 3 to both sides of the equation. Adding a to each side brings the left side up to 3a. Adding 3 to each side makes the right side equal to 1, and we get a is equal to 1/3. So our solution set here contains the values 5 and 1/3. We now start looking at absolute values with inequalities, but this first problem has an equality there. So we're going to have y equals 8 or y equals negative 8. That's using our first property of absolute values. So our solution set will be 8 and negative 8. In part B, we need to take this absolute value less than and write this as a compound inequality. This will give us negative 8 is less than y is less than positive 8. Written in interval notation, this will be the interval from negative 8 to positive 8. In the third case, removing this absolute value using our third property, we will have y is less than negative 8 or y is greater than 8. Writing this in interval notation, we have from negative infinity up to negative 8, which we do not include, union from 8 to infinity.